So this is the second half of this video, and what we'll be doing is looking at okay, so we have just two problems. I believe it's just two problems that we need to get through in these notes for 2.4b, which is the second half of 2.4. And we're going to determine, just by looking at this function, where it is increasing, decreasing. We're going to find the relative extrema, where they're located, and we're going to show the analysis that gets us those answers. So a lot, and that's why we're only getting through two problems on this slide. But all you need to do is identify the derivative. So if I ask for the derivative of this, well, you'd bring the 5 in front. 5 times 3 is 15. Subtract 1 from your exponent. And then, again, bring the 3 times 5 is 15. Subtract 1 from your exponent. And all you need to do is set this equal to 0. So from here, I can factor out the 15 and an x squared. And what I'm left with is x squared minus 1 is equal to 0. So what I'm doing is I'm setting the derivative equal to 0 to find my horizontal tangent lines. So you may remember from pre-calculus that I made you learn this premise of multiplicity, that x equals 0 has a multiplicity of 2. And then this other piece, you'd solve for it by adding 1 over, and then you square root both sides, and you'd say, well, x equals plus or minus 1. So then in pre-calc, I made you create this sign chart that included -1. I made you write down 0 twice, because that was a multiplicity of 2, and then +1. And this sign chart is part of your justification. Because, so down here you write your x's. And what you can do is you can say, well, x is -1, the value of the derivative would equal 0. And I hope you'd agree, because you would have, what, 15 times 0, which equals 0. Same thing down here. Plug in 0 for x. Well, 0 times anything is still 0. Same with this 0. Plug in 1 for x. Well, you'd have 15 again times 0, which is 0. And the reason why the sign chart works is when you pick a value that's to the left of -1, let's say -2, what's going to happen is you're going to have a negative value here, a negative value for that piece, negative and negative, and you have a negative times a negative times a negative times a negative, which gives you a positive answer. So what this sign chart is showing me is that the derivative is greater than 0. In other words, the function is increasing on the interval from -infinity to -1. Now, again, I'm going to use a bracket to explain that. You may also remember in pre-calculus that I taught you the shortcut that all values to the left of 0 are negatives. Here's your shortcut. And then all the values to the right are going to be positives. Now, what you have to be careful of is if you ever have a negative leading coefficient, you have to flip this, flip everything. But as I work through it, well, I have 3 negatives here, so that's negative. I have 1 negative, so that's negative. And a positive times a positive times a positive times a positive is positive. So the function is also increasing because the derivative is greater than 0 from 1 to infinity. And with the same premise is the derivative is going to be less than 0 on the interval from -1 to +1. So let's see what questions we have to answer. We just answered where the function's increasing and where the function's decreasing by using our sign chart. We also want to tell the extrema. Find the coordinates. That's important. You change colors. Let's go to red. The coordinates. So when you're asked to find the coordinates of the extrema, that's the x and the y coordinate. So as we look at this, the function changes from increasing to decreasing at x equals -1. So if we're changing from increasing to decreasing, that means we're going, sometimes I draw it right here. You know, it's a positive slope, means we're increasing to decreasing. That means we need to have, and if you connect those dots, a relative max. Relative max. Now, there's two ways of doing this. You can either give the ordered pair, or you can say the relative max value is the y value. Well, how do you find the y value? Is you go back to the original function that's up here, and you figure out what f of -1 is. Well, -1 to the 5th power is -1, so -3. And then -1 cubed is -1 times -5 turns out into +5. So you get 2. So the relative max value is 2. Same thing goes as we look at changing from a negative slope, so it's going down, to a negative slope. Well, does that mean we have a min or a max right there? No, it doesn't change at all. So x equals 0 is neither a min or a max. But at x equals 1, again, it goes from decreasing, a negative slope, to a positive slope. So decreasing to increasing means a relative min. And as you plug that into the original, the value is, let me scroll up, 3 minus 5, so it's going to be -2. I think we've answered every question, and there's no need for a calculator. I think I'll show you a calculator real quick just to prove that we are correct. Otherwise, pause the video. I'm going to scroll up and show you the graph. So you can just go into, sorry, I hit the wrong thing, y equals, clear this stuff out, negative, I already forgot what it was, 3x to the 5th minus 5x to the 3rd. I'm going to hit zoom 6 to go back to my standard window, and it looks exactly like I said. A relative max at -1, 2. There's no extrema at x equals 0. A relative min at 1, -2. And I had a really good student about 4 or 5 years ago that just memorized, you know, the positive leading coefficient, the odd degree, and so that individual knew, well, my end behavior, you know, needed to look something like this. Now, he or she didn't necessarily know how many curves we had in there or how many, but definitely knew that it was going to be increasing first, decreasing somewhere in between, and then increasing to the right, which I thought was a good move. Now, I don't know how that person would have done this next problem because it's not necessarily a polynomial, but we can still do this using the same tactics. Find the derivative. So the derivative of this is 1. The derivative of sine is cosine. Now we only care about between 0 and 2 pi, but this is why we need to understand trigonometry from before. To find relative extremity, you take the derivative and set it equal to 0. So that tells me that cosine of theta needs to equal subtract 1 over and divide by 2. Well, where on the unit circle does cosine equal a negative? Well, the first time is in the second quadrant. At that ordered pair, it's -1/2 root 3 over 2. So again, I care about the x-coordinate for the unit circle, so that's happening at theta equals the radian measure right there is 2 pi over 3. But it also happens in the third quadrant because it's negative, and that is 4 pi over 3. Now, you could still make a sign chart. I just think making a sign chart, you know, probably is not the way to go in this problem. So I'm going to show you another tactic, which you have to be careful of because they don't always accept this on the calculus exam, is to just put these down as if it's a derivative and then plug in values that are between the interval, because we only care about between 0 and 2 pi. So starting at 0 and ending at 2 pi, and plug in values in between. So let me change to a different color. So maybe try, I don't know, pi over 4. That's bigger than 0 but smaller than 2 pi over 3. It's right here in case you want to know. Maybe try pi, because that's right here. And then maybe another value, I don't know, over here would be like 7 pi over 4. So as I plug in these values into the derivative now, okay, and all I care about is, okay, well, pi over 4 cosine is positive here. So notice I'm plugging into the derivative because I care about if the derivative is positive or negative. I get a positive plus a positive, which is a positive. What if I plug in pi? Well, pi right here has the x-coordinate of -1. Well, 1 minus 2, because 2 times -1, 1 minus 2 gives me a negative. And then the 7 pi over 4 also gives me a positive. So that's how I would do this problem. So what does that mean? That means f prime of x is positive. I guess I didn't say it over here, but I was implying that that's your implication, that the derivative is positive means the function is increasing, and that's on the interval. I'm not going to include 0 because they didn't ask you to include it up here. By the way, they'll probably tell you if they want an open interval or not, but because they don't specify, I'm going to make it closed for 2 pi over 3 because the derivative was positive, and then from 4 pi over 3 to 2 pi. So for the sake of ease, I'm just going to write this out. So where the derivative is negative means the function is decreasing, and that is where we're negative. So that is the interval from 2 pi over 3 to 4 pi over 3. Now we still have one more thing to do, and that's to determine if it's a min or a max for these values. So if we're going from a increasing function going up to a decreasing function, and it's going to be connected because these are continuous functions, we're at x equals 2 pi over 3. That is a relative max. And I just like writing it as a value. And where do you go to find the value is back to the original function. So the original function, I'm going to figure out what f of 2 pi over 3 is. So that's going to equal 2 pi over 3 plus 2 times, now I need the sign, the y-coordinate. So that's root 3 over 2, and these would cancel. So I would just write it like that, 2 pi over 3 plus root 3. And then we also have the same thing at x equals 4 pi over 3. But this time it's a relative min. I'm trying to hurry. The reason why it's a min is our function is going from a negative slope decreasing to a positive slope increasing. There's a quick explanation, but now we have to plug in 4 pi over 3 up here, which a lot of the stuff is the same except it's 4 pi over 3 minus 4 pi over 3 minus root 3. There you go. I think you're ready for the homework now. Feel free to pause at any point and move forward.